There we go. Sheesh. You know, I swear, I test the technology like first thing this morning, and I'm like, okay, systems are a go. Let me just hang out, chat with all of you guys. And then I go to click the camera, and it's like, nah, not interested. I'm good on that. I'm good on that. Let's do a quick recap of simple interest problems using systems of equations. So last time I asked you to look at numbers 10, 11, and 12. I have completed number 10 so that I can show you and share that with you. I'm hopeful that you guys checked out number 10 at least, even if you didn't do all three of those. So let's take a look at the notes so I can show you what that looks like. All right, so notice here how we have Taekwon invested $30,000 for 1 year in two separate accounts paying 3% and 4.1% annual simple interest. Josh, that's awesome to hear. That's very, very, very awesome to hear. If Taekwon earned a total of $1,091.73 from the two investments, how much was invested in each account? So notice what I did first. I created my chart. My investment was $30,000, so that goes in place of your total principal investment, right? It's invested for 1 year. The two accounts pay 3% and 4.1%. We learned that when we make this, not really a substitution, but when we plug this into our chart, we write it in decimal form, right? So we turn it from a percent to a decimal by dividing by 100. We notice that Taekwon earned a total of $1,091.73, so that's total interest. It doesn't have to say that it's total interest. You can only earn interest, right? When you invest, you're earning interest. It's accruing that interest. From the two investments, how much was invested in each account? Nice job, Cece. Notice we are investing an unknown amount in account 1 and another unknown amount in account 2. We don't know what those are, but we're going to invest A and B in those. The interest from account 1 is 0.03 times A times 1, which is 0.03A. The interest from account 2 is B times 0.041 times 1, which is 0.041B. We know that because principal times rate times time is equal to interest. Once we have our chart completely filled out, we can take the principal from account 1 plus the principal from account 2 equals total principal. Doesn't that make sense? They should go together. That's logic. For our second equation, it's the interest from account 1 plus the interest from account 2 equals total interest. Remember, Taekwon's making money here, so we're going to add his money together. So here's our system. I chose to use elimination again because that's my preferred method. So I noticed that because my coefficient here is 0.03, it's a positive, I want to multiply the first equation by a negative 0.03. Remember that when we multiply, we have to distribute to all of the terms in the equation, otherwise it's not balanced. When I distribute, I get negative 0.03a, negative 0.03b, and then a negative 900. I rewrite the second equation, and then I combine in column form. Notice these are opposites, so they definitely cancel each other out. When I punch this in together, I get 0.011b. When I punch this in, I get 191.73. Divide both sides by 0.011, and we find that in our second account, we invested $17,430. As a reminder, we know that we have $30,000 invested total. So if in the second account you have $17,430, you want to say what's left over. And what's left over is $12,570. So your answer is here. All right. What I'll do today, since I have some extra time, I will email you the answers for 11 and 12. All right. For now, it's time. Let's move into mixture problems. Da, da, da. All right. For all of our mixture problems, I love using this graphic organizer. The box plus box is equal to box. I love this graphic organizer because it really helps us to kind of see everything that's happening. More often than not, for all of these problems, we have two ingredients or two solutions that we're mixing together to make that mixture, right? So it's like, almonds and walnuts. We make a mixture of almonds and walnuts. It's like Twix and Snickers, and we're making a mix of Twix and Snickers, right? So we have the two ingredients that we're going to add together, and we're going to combine them to make a delicious mixture. Unless it's a solution of acid, and then that's not delicious at all. So notice that I've separated the boxes in half, right? It's not a fraction. I've just separated the boxes in half. And the reason I've separated the boxes is because I want you guys to think about what it looks like in the real world. So for instance, let's say that we went into our favorite grocery store, right? And we go to the produce section and we say, you know what? I think I want to purchase some Honeycrisp apples because they're delicious. And I love using Honeycrisp apples as an example because they really are freaking delicious. So let's say that I asked you to buy Honeycrisp apples for me. And then I say to you, do you know how much it's going to cost? Well, you're probably going to ask me a couple questions, right? You're thinking about that and you're like, well, if I want to buy her Honeycrisp apples, I need to know how much it's going to cost per pound, right? So the cost per pound. And I also need to know how many pounds. So let's say that I told you that Honeycrisp apples were $2.59 a pound. And then I said to you, I need 6 pounds. So if I need 6 pounds of Honeycrisp apples that cost $2.59 per pound, you know how to calculate this in the real world. You know that in order to figure out how much this is going to cost before tax, you would take the 6 pounds and you'd multiply it by its cost per pound, right? Every pound is $2.59. So it would make sense that you'd take the $2.59 and you'd multiply it by the 6. Does that make sense? When we multiply those two values, we've just found the value of those Honeycrisp apples. So what's happening with these kinds of mixture problems is that we have two different ingredients with two different values, and we have to figure out how they come together, essentially. Okay? So I'll show you. It's actually really not bad. It's not bad at all. The only thing that trips people up is they will tend to put information in the wrong places. So as you dissect your charts, be super critical about where everything should go. Okay, all right, let's go to the notes and I'll show you what this looks like. I think you'll end up liking it quite a bit. Guys, we have 4 dogs in the house. Okay, let's go to the notes. When we write out our two equations, our first equation deals with value, right? So the value is cost times amount. And what we're going to do is we're going to take the value of item 1, we're going to add the volume of item 2, and we're going to set it equal to the value of our mixture. That's one of our equations. Now, if we choose, and we are going to do this more often than not, so if we use two variables, then our second equation, because we need 2 equations, right? 2 equations with 2 unknowns. Then our second equation is the amount of the first item plus the amount of the second item equals total amount. And again, I hope you don't mind me abbreviating. Next semester, I'm going to include this into my notes. Okay, if we use 2 variables, and our second equation is the amount from the first one plus the amount from the second one equals the amount of the mixture. It's going to actually be really, really cool. Just remember that these are our 2 formulas. Okay, let's check this out in action. JB owns a nut shop. He sells almonds for $6 per pound and walnuts for $5.20 per pound. He receives a special request from a customer who wants 30 pounds of a mixture of almonds and walnuts that sell for $5.50 per pound. Determine how many pounds of walnuts and almonds should be in this mixture. Okay, no big deal. I'm going to set up my boxes and I hope you do the same. Box plus box equals box. We're going to separate the boxes into 2 pieces. Okay. Notice that my ingredients are almonds and walnuts. So I'm going to label the first box almonds and the second box, oh man, this ink, walnuts. And the last one, let's just call it our mix. Okay, very cool. Notice we have 2 units of information. We have cost per pound. So the cost per pound, I'm going to put that in the top row. And then we have the number of pounds. So I'm going to write pounds for our second row. Now that everything has a label, we can literally substitute all the values where they're supposed to go. He sells almonds for $6 per pound. Okay, almonds are $6 per pound. Walnuts are $5.20 per pound. Take a look at where we're placing this. So I'm just going to put a check mark, put a check mark. He receives a special request from a customer who wants 30 pounds of the mixture. Well, that's easy. This is a cost per pound. This spot is the number of pounds. So he wants 30 pounds of a mixture. Cool, we'll put that there. And that sells for $5.50 per pound. Okay, we have the cost per pound. Let's go ahead and put it where it belongs. Then it says determine how many pounds of walnuts and almonds should be in this mixture. So we don't know either value. We don't know how many almonds we have, so let's call that A. We don't know how many pounds of walnuts, so let's call that W, right? Why not? We'll make it easy. There are 2 equations. We have the value of item 1 plus the value of item 2 equals the value of the mixture. So the value of our almonds will be 6A. The value of our walnuts will be 520W. And the value of my mixture is going to be 550 times 30. So 550 times 30 is going to give us 165. Okay, if you want to make a note in your notes how you got this value, go ahead. Remember, it's just the value, so cost times amount, plus the value, cost times amount, is equal to the value, cost times amount. That won't change. Your second equation is the amount of almonds plus the amount of walnuts is equal to the total amount. So it's going to be A plus W equals 30. And there's our system. Not bad, right? So now we're going to solve this system. I'm going to speed through this just a little bit since we've done a bunch of these already. I am going to use elimination. Again, that's my preference. You can use substitution if you would like. In this case, when I look at the A and W variables, I notice, or the coefficients rather, I notice that the W has the smaller coefficient. So I'm going to take the second equation and I'm going to multiply by negative 5.20. So that way my W's will cancel. As a reminder, we distribute to all 3 terms. So let's see what we get. The first equation is going to stay exactly the same. 6A plus 520W is equal to 165. And now I'm going to distribute the negative 5.20 throughout. Be so careful with the signs, please. Negative 5.20A, negative 5.20W is equal to negative, let's punch this in, so 5.20 times 30 is going to give me 156, so it's a negative 156. Awesome. At this point, notice my W's will cancel, so that's pretty cool. I don't have to worry about those. I was successful in my elimination. So we're going to take 6A and subtract 5.20A. If you plug that in, think about it as $6 minus $5.20. So you're left with 80 cents, correct? So you should get 0.80A or 0.8. So either one, 0.8, 0.80A, whatever you'd like, you can do either one, okay? Is equal to, and if you have 165 minus 156, you'll end up with 9. If we divide both sides by 0.80 or 0.8, we'll end up with 11.25. And that's okay in this case, no worries. Notice it's asking for the number of pounds of walnuts and the amount of almonds in pounds. So notice we found A. A represents the pounds of almonds, so that part's done. Notice that there's a total number of pounds of 30. So if the total number of pounds is 30 and there are 11.25 pounds of almonds, then to figure out what's left, we would just subtract. Okay, so as a reminder, if you have A plus W is equal to 30, we know that A is 11.25. If you want to show the work, go ahead and make the substitution. Subtract the 11.25 from both sides, and you find that W is equal to 18.75. As always, let's write our answer here. And that is for almonds, we have 11.25 pounds. That's why I used A. It makes life really easy because once we solve, we know exactly what we solved for. And then W is walnuts, and W is 18.75 pounds. And you are done. So Queen, you asked a really good question here. We're going to use two equations in this case because we have two unknowns. Anytime we have two unknowns, we need two equations in order to find those two unknowns. If we have three unknowns, we actually need three equations. If we have four unknowns, we need four equations, etc., etc. Okay? So I want you to think about, the idea of solving for each of these unidentified amounts, and considering that because they're not identical, we don't know whether or not they're the same amount. It could have been 15 and 15, right? Because 15 plus 15 is 30, but we didn't know that. So we have to treat them like they're different amounts, which means we need to use different variables. Okay, excellent question. All right, let's take a look at the next problem. Charisse is the owner of a Starbucks coffee shop. She sells blonde roast coffee for $6.20 per pound and pike roast coffee for $5.80 per pound. If she uses 18 pounds of the blonde roast coffee in the mixture of these types of coffee and sells the blend for $6.10 per pound, how many pounds of the pike roast coffee should she mix with the blonde roast coffee? And you're welcome, Queen. So we're going to set up our chart again because we know this is a mixture problem. Box plus box equals box. Divvy the boxes up into two pieces. And we know that we have two ingredients here that we're mixing. We have our blonde roast coffee, so let's call that blonde. And we have our pike roast coffee, so we'll call that pike. And we're making a mixture of the two. We also have the cost per pound. So I'm going to write cost per pound, which means my second row in each of these boxes will refer to the weight, pounds. All right, let's fill this in. So she sells blonde roast coffee for $6.20 per pound. Okay, so we're going to punch that in right here. $6.20 per pound. Check. She sells a pike roast coffee for $5.80 per pound. So let's put that right here. Okay, perfect. Now, notice what it says. If she uses 18 pounds of the blonde roast coffee, so 18 pounds of the blonde roast coffee. So that means we know the weight for the blonde roast. We put it exactly where it belongs. We don't overthink it. We simply say, okay, we know we have 18 pounds. Boom, let's put it in there. Okay, so 18 pounds of the blonde roast coffee are used in the mixture of these types of coffee, and she sells the blend, which refers to the mix, she sells the blend for $6.10 per pound. One thing that I want you to consider is, I know it says that she's using 18 pounds of the blonde roast coffee in the mixture, but it doesn't mean that the mixture alone is only 18 pounds, right? We know the mixture consists of two types of coffee, the blonde roast and the pike roast. So we know that they have 18 pounds of the blonde roast, which means we don't know how many pounds of the pike, which also means we don't know exactly how many pounds are in our mix. So let's call this pike roast P, and we'll call our mix M because we just don't know it. Okay, we have two unknowns, so we use two different variables. I like P for pike and M for mix. It just makes life really easy. So recall we have two equations. We have our value and we have our amount. So let's start with the value. So the value of our blonde roast is going to be 620 times 18, which is 111.6. Then we have plus. The value of pike is going to be cost times amount, 580p. And the value of our mixture is 610m. Okay. Our second equation deals with just the weights. So as we go from left to right, the 18 pounds of blonde plus P pounds of pike equals M pounds in our mixture. There you have it. And voila, we have our system. Now, I'm actually going to rewrite this system, but I'm not going to use elimination this time. And I'm going to show you why that is. So I'm going to rewrite my system here. 111.6 plus 580p is equal to 610m. So CC, I got the 111.6 by taking the 620 here for our blonde roast. So the cost per pound is 620 and we have 18 pounds of it. So if every pound of the blonde roast costs 620 and we have 18 pounds, we have to multiply. So that's where I got the 111.6. It's $111.60 essentially. So remember, our first equation deals with value. So cost times amount, here it is, plus cost times amount, here it is equal to cost times amount, here it is. So the first equation deals with value. The second equation is just amounts. So now I'm going to write this second equation underneath, and I want to show you guys something. So in this case, we'll use substitution because I know what M is. M is 18 plus P. So if M is this expression, 18 plus P, then I'm going to take this 18 plus P and plug it in for M in our first equation. I'm making a substitution. So I'm going to write in here, substitute. Rewriting the equation gives us 111.6 plus 580p is equal to 610, and then M is being replaced by its expression because we know M is 18 plus P. So we're going to substitute that right here. And now all we have to do is do the math. This takes us right back to chapter 2. 111.6 plus 580p is equal to, we'll do 6.10 times 18, and that gives us 109.8 plus 610p, and let's just continue solving. I'm going to bring the 580p over. I always like working with the variables first, and I urge you guys to do the same. Dealing with the variables first is a great way of identifying if you end up having a solution or if you end up with a result of infinite number of solutions or no solution. Okay, so that's why I always move the variable terms first. So we have 610p minus 580p, which is a positive 0.30 or 0.3p. So if you punch that into your calculator, you would actually just get the 0.3, so I'll write it that way. Now we're going to subtract the 109.8 to bring it over to the side. Again, consider that if we move the term from the left to the right, chances are we have to move a term from the right to the left in order to solve. So it's that dance that we talked about in a class, moving from left to right or right to left. These two cancel each other out, so we have 111.6 minus 109.8, and that gives us 1.8 is equal to 0.3p, and now we just have to divide both sides by 0.3. So 1.8 divided by 0.3 gives us 6. Very cool. Now again, we're not done. We always have to have an answer section to our word problem or for our word problem. If P is 6, we know that P represents the number of pounds of pike roast. So this means that there are 6 pounds of the pike roast. So I'm going to write here for my answer that there are 6 pounds of pike roast. Now I want to check again. It says, how many pounds of the pike roast coffee should she mix with the blonde roast coffee? Perfect. We have successfully answered that question. I always like to go back to the word problem to make sure that there wasn't something else that we were supposed to provide. Like for instance, I could have asked how many pounds were in the mixture altogether. If I ask that question and you know that there are 18 pounds of blonde and 6 pounds of pike, well then there must be 18 plus 6, which is 24 pounds of the mixture, okay? And that's a little side note you can add, that there are 24 pounds of the mixture, but that's completely up to you. We answered the question successfully, so we are all set with number 14. The really great thing about these mixture problems is that they all are essentially the same format. You have your box plus box is equal to box. You split them up, you figure out what the top row refers to, you figure out what the bottom row refers to, and then you just plug in the values. You know how to plug these values in, and you know what the two equations should look like. So I want you to continue to practice that idea as you do these at home and as you do them in Lumen, okay? So let's do number 15. For number 15, we're actually looking at solutions this time, where they have a concentration instead of a cost per pound. The idea doesn't change. The equations, the setup, they don't change. So you have to be very comfortable with saying, all right, I know what the setup looks like. Sure, we're dealing with percentages this time, but it's not a big deal. Okay, let's take a look. So we have Clorox bleach is 5.25% sodium hypochlorite, and swimming pool shock treatment is 10.5% sodium hypochlorite. How much of each item must be mixed to get 6 cups of a mixture that is 7.2% sodium hypochlorite? Okay, excellent. Thank you, Doc. I'm glad to hear it. So let's take a look at this by setting up our boxes and labeling them and all that good stuff. So we have our first box plus our second box equals our last box. Sorry, my box looks like crap. Okay, we have 2 ingredients. We have Clorox bleach and we have swimming pool shock treatment. So I'm just going to call this one bleach. And then this one's swimming pool shock treatment. So maybe I'll just call it pool. Is that okay? I'll just call it pool. So we know what that means. And then we have a mixture. All right. We notice that we're talking about the percentage of sodium hypochlorite. So I'm going to write percent sodium hypo, and I'll put a period, hypochlorite. And then we also know that as we scan this, we say how much of each item must be mixed to get 6 cups. So we know our unit in terms of amount is going to be cups. Our chart is completely labeled, so now let's fill it in. Clorox bleach is 5.25% sodium hypochlorite. So remember, this is a percentage, which means when we plug it in, we must convert to a decimal. All you do is take this number and divide it by 100. If you divide it by 100, that essentially means you move the decimal 2 places in. So you should get 0.00, nope, let's try that again, 0.0525. I apologize for misspeaking. So we move it 2 places, so 0.0525. That takes care of the Clorox bleach. Let's go to the swimming pool shock treatment. It's 10.5%. So let's move it in twice, just like we did before. That's dividing it by 100. So it's 0.105. Check. how much of each item, so we don't know how much of each item we need. So maybe I'll call this B for bleach, and then P for pool. We want 6 cups of a mixture, so we're going to put the 6 here. And we want it to be 7.2% sodium hypochlorite. So again, move the decimal in twice, and this will be 0.072. I could put zeros right in front of these if you want, if it makes you happy. Okay, so we have our, oh, Christine, that's a great question. No, these are not distance problems, so you don't need to pick out any particular scenario. The really cool thing about mixture problems is the setup is always the same. It's the box plus box equals box. And then you write out your 2 equations and you use whatever method you like to solve it. Okay? So let's write our system. Remember, value is cost or concentration times amount. Value, cost or concentration times amount, and same thing, the value is cost or concentration times amount. So the value of my bleach is going to be 0.0525B plus the value of the pool is 0.105P is equal to, and then the value of the mixture is going to be the product of these two. So we're going to take 0.072 and we'll multiply that by 6 to get 0.432. 0.432. So that's my first equation, the value of each. You're welcome, Christine. So the second equation deals with amounts. So it's B plus P equals 6. The amount plus the amount equals the total amount. So B plus P is equal to 6. I think the hardest part about these particular problems is that we can get our decimals all mixed up. As you saw here, I almost made that mistake at the very beginning. And you want to be really, really careful, okay? Josh, I see you all in my live chat. Everyone has checked in by saying hi, so that's how I'm keeping attendance. Thank you for asking. So now I'm going to write both of these equations here, and again, I'm going to use elimination because that is my preferred method. So we've got 0.0525B plus 0.105P is equal to 0.432. As you do problems like this, I would just double check to make sure that your decimals look good, okay? Right, Sydney, as long as you say hi in the chat, I'll know that you're here in attendance. So thank you for checking in. Okay, so the next one, again, I'll write directly underneath. And out of these two coefficients, my 0.0525 is smaller than my 0.105. Think of this as like 5 cents and then 10 cents. Okay, so if you just cut off the last 2 digits, the last one, just to check it out, 5 cents versus 10 cents, this is smaller. So we're going to take the second equation and I'm going to multiply by the negative 0.0525 coefficient instead. So negative 0.0525. Again, we always distribute just like so. And let's rewrite. All of this rewriting, just be super careful, okay? Pay attention to all your decimals. Don't add an extra 0 when there isn't an extra 0, like I almost did. Now let's distribute the negative 0.0525B, negative 0.0525P is equal to, now let's multiply these two guys. So negative 0.0525 times 6. And I'm being like so careful when I punch this into the calculator. That gives me negative 0.315. Good. Okay, excellent. Notice my B's cancel, which is exactly what we wanted. We wanted to be able to eliminate those two, so that's a success. I'm going to punch this into my calculator exactly as I see it. It's a positive 0.105 minus 0.0525. That gives me a positive 0.0525p. Now let's punch that in. 0.432 minus 0.315. I'm double checking my calculator. And we get 0.117. All right, as long as you're taking the time to punch it in, you'll be just fine. Divide both sides by the coefficient of p in order to get p isolated on its own. So we divide by 0.0525 and we get, so how about we round to the nearest tenths? So that's going to be 2.2. Okay, we're going to round to the nearest tenths position, and that is 2.2. Now, when you think about this, it says how much of each item must be mixed to get 6 cups. No, Josh, that's a 0.072. Hopefully that helps. We didn't need the 0 there, but I just figured in case you wanted to put a 0 in front of it, you can. So that's just a 0.072 because we converted the 7.2% into decimal format. All right, so we know that P, which represents the pool shock treatment, the cups, so there are 2.2 cups of the pool shock treatment. But we know there are 6 cups total. So if we take this B plus P is equal to 6, and we plug in the 2.2 for P, we can solve for B. So B is equal to 6 minus 2.2 gives us 3.8. Okay, hopefully you guys could still see that in the screen. It should be just fine. So let's write our answer. We know that there are 2.2 cups of the pool shock treatment. Always double check. Everything's labeled, so it's really nice. You could just double check to see where we are. So there are 2.2 cups of pool shock, right? And then according to our math, we have 3.8 cups of, and let's go here, we know that B stands for bleach. So 3.8 cups of bleach. And what do you know? That's it. That's all you have to do. I am hopeful, yeah, I wanted to share that. I am hopeful that this is actually clear for you guys in terms of the setup and writing the equations and then using, I prefer elimination. I think that's a great choice, by the way. Some of these will end up being really nasty if you try to do substitution. I use substitution for number 14 because it was already set up that way. I had m is equal to 18 plus p, so it made sense. I knew what m was. M was that expression, 18 plus p, which I could then take and plug into the first equation. So for number 14, substitution was awesome. It was perfect. But if you look at 15 and you wanted to use substitution, that's fine, but I would urge you to manipulate the second equation. I would urge you to manipulate the b plus p equals 6 and solve for either b or p, and then plug that into the first equation. If you tried to isolate one of your variables in the first equation, the one that's 0.0525b plus etc., you're going to end up with rounding errors. So I would urge you, if you're going to use substitution, manipulate the easier equation. Manipulate the b plus p is equal to 6. Manipulate the one that has coefficients of 1. Remember, a long time ago when we first started this unit, we talked about strategies. We talked about what is the best approach. That way you can avoid any of the calculation error. Okay? Hopefully you heed that warning. That's why I like elimination. You don't even have to worry about that. Let's turn the page, look at another one. To make an interesting concoction, D. Lynn Proctor, a well-known African-American sommelier, that's someone who's an expert in all things wine, chooses to combine 2 red wines. He mixes 5 liters of a Shiraz, that is 12% alcohol by volume, with 2 liters of a Pinot Noir that is 9% alcohol by volume. Determine the alcohol content of the mixture. I would like you guys to give this one a shot. So I'm going to give you about, let's do 3 minutes because our class is almost done. We'll do 3 minutes and then we'll look at this together. Okay, so let's actually plug in the information that we have here. We notice that, Crystal, let's meet in Zoom right after this. So he mixes 5 liters of a Shiraz, so 5 liters of a Shiraz. That is 12% alcohol by volume, so this is 0.12. And he mixes it with 2 liters of a Pinot Noir, 2 liters, that is 9% alcohol by volume, 0.09. Determine the alcohol content of the mixture. So this is an interesting perspective. It says determine the alcohol content of the mixture. That means we don't know this one. We don't know the alcohol content. Now I want you to be critical. If Dylan Proctor is mixing 5 liters of Shiraz and 2 liters of Pinot Noir, well, you know how much is in the mixture. That's 7 liters, right? He mixed these 2 wines together, so altogether there's 7 liters. Now the super cool thing about this, guys, is that there's only one unknown. So we don't need 2 equations anymore. We only need the one. And we know that because our amount equation would be 5 plus 2 is equal to 7. And I would say, yes, that's totally true. So we need our value problem, which is going to be 0.12 times 5. So we're going to do let me clear this out, 0.12 times 5. And that gives us 0.6 plus, then we do 0.09 times 2, which gives us 0.18. And then we have A times 7, which is just 7A. Again, as a reminder, we get 7 liters because we're mixing 2 wines. If there's 5 liters of Shiraz and 2 liters of Pinot Noir, well, altogether you have 7 liters of the mixture. Let's combine like terms. This gives me 0.78 is equal to 7A. I'm going to divide both sides by 7, so 0.78 divided by 7. And I find that I have an alcohol content of, let's write 0.11 is equal to A. This time we'll round to the nearest hundredths, only because I have two places in my percentage. So this refers to, let's write our answer, the alcohol content is 11%. Okay, that should make sense. If one of your wines is 12% and the other is 9%, the 9% is diluting the stronger one. So when we combine these, we ended up with an 11%, somewhere in between the two. That should make sense. On your own, as a challenge problem for another bonus point, another bonus test point, I want you to try number 17. If you get 17 correct, you will get 2 bonus test points, okay? So 2 of them if you get this correct. But I can't give you any hints. So either it's right or it's wrong. But you could submit multiple answers, okay? I'll just tell you whether or not it's right or wrong. Stay safe, stay healthy. I will see you guys tomorrow for our final day of week 10. See you guys. Oh, dropped my pen.